How are you, everybody who is watching this video? I would like to take this opportunity to welcome some physical ordinary diploma engineering students at one of the very interesting institutions in Tanzania, Dar es Salaam Institute of Technology. And I would like to also take this opportunity to welcome some online students who are in other institutions or other colleges or universities, or even those who have been interested with telecommunication engineering. It's the first time to meet me. My name is Olenjolai, and I'm very happy to have you today. I would like to ask you just an apology at the beginning. Today my voice is not good. I'm just have some health problem, but should not worry because it won't affect anything. Just the audibility of my normal voice might be a little bit different. So I would like to take this opportunity to welcome you in lecture 7, when that we are going to discuss about principle of operation of the PAS primary radar receiver. In previous lecture, we've been discussing about the principle of operations of PAS primary radar transmitter. I'll be just doing the quick review in case you have missed it, but actually you have to go through it because you can access this content. Remember that this is a telecommunication module, or it's a telecommunication course. So we ask students to be serious, and there's not a lot of requirements, just a fresh mindset. You need just a pen, just like myself, I have a chalk to teach you. You need a pencil in case of the drawing, and also you need a rubber and a ruler. Those are the very important requirements. So make sure that you make a follow-up and you follow along. In case you have any question, don't hesitate to ask it, whether physically for some physical students, or you can ask it on the comment sections of the video that you're watching right now. So for me, I thank God I have been well prepared to teach you. How about you? Hopefully the answer is yes. So let me appreciate the presence of some physical students. How are you, students? Yeah. Okay, are you ready for lecture 7? Yes. Yeah? What the title of lecture 7? Yes, so it means that in previous lecture, we have discussed about principle of operations of radar transmitter, where we discussed how many blocks? 60 blocks. Very good. So now before we dive into the principle of operations of PAS radar receiver, let us do the quick review and remind ourselves about what we have covered in workshop 6. So the first concept that we've covered, I think I've reminded that the three main parts of any radar system, whether it is primary radar system, or secondary surveillance radar system, any radar system consists of three main parts, which is a little bit different from three main parts for any telecommunications or any communication system. And those parts that we say that the first one is transmitter unit. Then any radar system must consist of antenna. Say antenna. Say antenna. And then any radar system must consist of what? Receiver unit. Are we together? Yes. Then the next concept, we discuss about the principle. And then we say that whenever we discuss about principle of operations of what? Of pass radar. Then simply we have a responsibility to understand how does each block work in order to facilitate or in order to complete the communications or the radar communication system, right? So we are responsible to explain, whenever you ask the principal operation, we have to explain the primary function of each block. Because sometimes in the general block diagrams of the pass radar system, you might find that one block performs more than one function. So you have to identify the primary function, and then you have to include it in the principal operations of the pass radar in case you have been asked to do so. Then the next concept, we discussed about the first block, which is pass generator, right? Pass generator, we say that it's electronic circuit or piece of the testing instrument that generates rectangular. Say rectangular. So rectangular passes, or rectangular short bursts of of passes, right? Then we discussed the second block, which is RF oscillator. Say RF oscillator. So the RF oscillator, its main function is actual generates the carrier, the RF carrier signal. Then the third block that we have discussed is called what? Pardon? Pulse modulator. So pulse modulator, this one, it's a unity that combining the pulse as the information signal, plus what? The carrier signal. And then the result is what we call the pulse what? Pulse what class? Modulated what? Modulated signal. You just apply mathematics on learning telecommunication engineering. So pulse as the information signal plus carrier signal, you get pulse modulated what? Signal. Simple like that. Then the next block, the first block is what? Radar transmitter. So radar what? Transmitter. Simply we just call TTX. What the primary function of the radar transmitter? So it has two primary functions. The first one, the first primary function of the radar transmitter is actual to amplify the pulse modulated signal. To form what? Amplify the pulse modulated signal. Right? So it means that when you have pulse modulated signal, then we introduce it into the amplifier. We are going to have amplified the pulse modulated signal. Are we together? Yes. So remember that we have been discussing the type of the signal, the block diagrams, the operations of that block diagrams, and also the waveform, if you do remember. And I told you that learn, understand, and think, because I told you that telecommunication engineering is all about what? Graphs. Telecommunication engineering is all about what? Graphs. It's all about what? Numbers. It's all about what? Diagrams. It's all about what? Blows. You don't mind, Then the next block is what? Pardon? Duplexer. What the duplexer? It's a telecommunication switch. What the principle of operation for duplexer? So a duplexer is actual connecting antenna either to the transmitter when it is connected antenna from the receiver. And then the duplexer connect the antenna to the receiver when duplexer disconnect the antenna from what? from the transmitter. Are we together? And I told you the principle of operation of what? Of replexer is just that one. To connect the antenna and special transceiver antenna to the transmitter while disconnect from the receiver, and connect to the receiver while disconnect from the transmitter. Wonderful. Then the last block is very important. It's called what? It's called what? Again. Again. Antenna. What is antenna? Antenna is what? Antenna is what? What does it transducing? It's a transducer that transducing what? Electric signal into electromagnetic waves during the transmission, and transducing electromagnetic waves into electric signal during the reception. Right? What are the principal operations of the antenna? Principle of conservation of what? Energy. Energy can neither be created nor, but it can be transformed from one form to another. That's all. So antenna is nothing. It's just the applications of Newton's law. Because that is, the law has been stated by Sir Isaac Newton. Okay. So let us move into today's lecture. So today's lecture, we say that it means pass, radar, receiver. So let us start with the first terminology, that radars, receiver. Radars, receiver. Say radars, receiver. Say radars, receiver. So let us have a short description about radar receivers in general, and then we'll dive into the pulse primary radar receiver. Right? So this is the point that you have to note. And this one. So we say that. Sorry, I think that let us focus about pulse, radar, primary radar receiver. Pulse, pulse, primary radar receiver. Pulse, primary radar receiver. Say pulse, primary radar receiver. So simply that, we say that the pulse, primary radar or radars receiver, we say that the pulse primary radar receiver must be a super heterodyne receiver. So this is the new vocabulary. Just like when you heard the word called transponder. So a radar receiver, first of all, or a pulse primary radar receiver must be super heterodyne. Say super heterodyne. Ask your neighbor, have you ever heard this terminology in telecommunication engineering? Yes. What the meaning of super heterodyne receiver? Pardon? An ability of the receiver to change radio frequency into intermediate frequency. Very good. Oh, good try. Another student? So this is the new vocabulary. Whenever you encounter any vocabulary, don't move forward about the radar receiver. First, try to understand. Because this is the very important keyword. The radar receiver must be super heterodyne receiver. So it means if you understand super heterodyne receiver, then you have a clear and a big picture about the radar receiver or the pulse primary radar receiver before you move to the next concept. So, ladies and gentlemen, let us learn the meaning of what is super heterodyne What it means of superheterodyne receiver. So what is superheterodyne receiver? Say superheterodyne receiver.
Superheterodyne receiver.
Then we say a superheterodyne receiver is a radio receiver. Say radio receiver.
Radio receiver.
Is a radio receiver that uses the principle of mixing, of frequency mixing, that uses the principle of frequency mixing. Say frequency mixing. Again, say frequency mixing. That uses the principle of frequency mixing to convey a received signal to the fixed intermediate frequency, which in short we call it IF, which can be more conveniently to be processed than the original carrier RF carrier signal received from the transmitter. So this is the meaning of superheterodyne receiver. Very important terminology in telecommunication or in communication engineering. Class again says superheterodyne receiver. So separating. A superheterodyne receiver, first of all, it's a radio receiver. It's not intermediate, it's not infrared receiver. It's not microwave receiver. Be careful. Whenever you mention microwave, be careful. Whenever you mention infrared, take a note. Whenever you mention just the infrared, take a note. Because for you, you can just focus about mixing the RF and actually converting the RF into intermediate. And then you forget some important keyword. If you do remember about duplexer, we say that it's a what? It's a microwave switch. Right? And this one, it's a what? As for heterodyne receiver, it's a radio receiver. That uses what? The principle of what? Frequency mixing. To do what? To convey what? A received signal, which in case of radar we call it echo, or reflected signal from the distant target. Okay? And then once it's received, then it's conveyed the received signal, they receive the RF signal. In most cases, it is RF signal. To the what? Into what? Fix the intermediate frequency signal. Fix the intermediate frequency signal. So it means that RF or radio frequency, it's one of the boundaries. Intermediate frequency, it's another boundaries. So remember, radio frequency is not equal with intermediate frequency. Radio frequency signal is not equal with intermediate frequency signal. Why? Because there's a difference in what? In frequency. So you have to remember about the boundaries of the RF, the boundaries of the intermediate frequency. Okay? Class, are we together? Yes. So this one is conveyed to receive the RF signal to the fixed intermediate frequency signal, which can be more convenient. Why do we need this conversion? The reason it has been stated in the next part of the sentence. It can be more conveniently to be processed by what? By the receiver, rather than processing the original RF carrier signal. So we need that conversion because it's simple to process intermediate frequency echo signal, rather than they receive the carrier signal. Are we together? Yeah. Are we together? Yes. Because somebody can challenge that. Why do we need to convey it? Okay, this is the reason. It's simple to process a fixed intermediate frequency signal rather than process a original received radio frequency carrier signal. And when the receiver receives this signal, where does it come from? It's come from what? Why do you call it come from transmitter? Because transmitter unit, or rather transmitter, it's a source. A target is just reflecting what has been propagated by the radar transmitter. Are we together? Class, are we together? Yeah. So remember that the transmitter is actual transmitter propagate what? Carry what? Oh, sorry. It's not the original received the carrier signal. No. It's original RF modulated. Pulse modulated signal. Sorry. Than the original RF, yes, modulated signal. Because this is general modulated what? Modulated signal. We are talking about this per heterodyne receiver. So remember that a receiver gives out RF modulated signal. Right? Right? Then here we have what? A target. We have a target. So when you have this target, the target reflect. Remember that this is just the electromagnetic waves. The target gives us the OT, and then the same antenna will receive the signal. But remember that this receiver must have the structure of converting what? The RF signal into intermediate frequency or into IF signal for processing. Are we together? Okay. So then let us go back to our general block diagram. Refer our general block diagram. Go back. Refer your general block diagrams of past primary radar. So we discussed about 6 blocks, as you say. The first one, pulse generator. The second one, RF oscillator. The third one, pulse modulator. The fourth one, transmitter unit. The fifth one is what? Duplexer. Then the next one is what? Antenna, where we have transmission and what? Reception. So how many blocks have remained for the receiver? 7. The first one, low noise radio frequency amplifier. The second one? Mixer. The third one? The fourth one? The fifth one? Detector. Then the next one? Video amplifier. Lastly? Cathode ray tube display. Right? Okay. So let us discuss them. So would you like to number is number 1, the first block to number 1, or to just number 7, eh? Number 7, eh? So number 7 is what? Low noise radio frequency what? Amplifier. Say low noise radio frequency amplifier. Again, say it. Low noise radio frequency amplifier. When we say low noise radio frequency amplifier, it means that it will be focusing on the received signal rather than introducing the noise into the signal. So this is the characteristics of this type of RF amplifier. It means that it has a low sensitivity, or it has actual, it does not have ability to amplify the received signal with noise, or to introduce noise into the received signal. That's why we call that low noise RF amplifier. Is it clear, or should I repeat? Let me repeat. Say low noise radio frequency amplifier. Before I explain what is it and what its main function in the pass radar and the pass prime and radar receiver part as a first block, then I want to tell you that low noise RF amplifier means that this is an amplifier which will be amplifying the received, the weak signal or the low power RF echo from the target or reflected by the target, right? But itself, it has a features of less introductions of the noise to the information signal or to the echo, and also itself it will not amplify the noise signal, which is unwanted signal. Matthew is busy. So a low noise RF amplifier is a first block in pass radar's receiver. That its primary function receives the low or weak, low power, that's equal to something equal to, receives the low power echo signal from the duplexer. So the primary function, one of the functions of the low noise radio frequency amplifier is actual, it should be able to receive, the low power. Say low power. We call it low power echo signal from the duplexer, or sometimes we call it weak echo signal or weak reflected signal. Echo signal from what? From the target. It has been reflected by authority by the target. So this low noise RF amplifier, it amplifies the weak or low power received signal. So its primary function, once received, its primary function is actually to amplify. Say amplify. It amplified the weak or the low power, received the signal. Low power, received the signal. So, the output amplify the echo, the outputs amplify the echo of the low power RF amplifier. RF amplifier is fed into the mixer. Fed into the mixer of pulse, radar, receiver. So once it's amplified into the desired signal strengths, then its output, amplified the echo of the low power RF signal, will be fed into the mixer of the pulse, radar, receiver. Are we together? Are we together? Then now, waveform. Waveform of amplified, waveform of amplified signal. Waveform of amplified signal. So the waveform of this amplified signal is this. Voltage, and this is time. Engineering is all about what? It's all about what? It's all about what? Eh? It's all about what? It's all about what? Huh? Mangoes? Numbers. Amplified RF echo signal. So ask your neighbor, where is your graph of telecommunication engineering that you drew on the graph paper in this week? Because your neighbor said that engineering or telecommunication engineering is all about the graphs. So tell your neighbor, today it's the end of the week. You are planning to have a very interesting weekend. Can you show me just the one graph of telecommunication engineering? So ask your neighbor, that's a serious question. Because your neighbor is always declaring, engineering, telecommunication engineering is all about the graph. You drew nothing. So you are declaring what you don't live in. Huh? Possibly you are declaring for others, not for you. Because if for you, you could have something to manifest. So the size of this different waveform is still the same. And this is, remember, we call it modulated signal. So it's amplified modulated echo signal. Amplified what? So it's called the waveform of amplified modulated RF echo. Modulated RF echo signal. So this is figure what? Figure number? 7. Figure number 7, eh? Mm-hmm. The waveform of 40? Amplified? Modulated? Okay. So this is the nature of the waveform that we'll see in oscilloscope. Because we use oscilloscope, whether it's analog oscilloscope or digital oscilloscope, actually to visualize the waveform. So we did not just develop this waveform from our brain. No, you can visualize them in the oscilloscope. And that's why that we have oscilloscope in industries or in manufacturing industries. Is it clear? Yes. Class, is it clear?
Yes.
Well, any question about low noise RF amplifier? No question. The next block is what? Mixer. The next block is local oscillator. You see the way that you mentioned those blocks without even thinking and just use your common sense? So what the mixer will mix? If you say the next block is mixer, what will it mix? Will it mix just the amplified RF echo signal? It's just, you just have to use your common sense. It's not something that with telecom. You are going or you are heading to the mixer. What are you going to mix? You have one item that's required in that mixer. How about the other one? Oh yeah. So the next one is local oscillator. Say local oscillator. Say local oscillator. How many types of oscillator do you have in electronics? Daudi? How many types of oscillator do you have in electronics? According to your basics of electronics. How many types? Holiness? Have you ever heard oscillator? Have you ever heard oscillator? How many types do you have? Hamza? Stand up. I'm just waiting the response from Hamza, and Hamza is slumbering. So we say that a local oscillator first of all, this one we say that a local oscillator is the oscillator used in super heterodyne receivers to produce signals signals or produce signals to produce signals having stable frequency. So the main function of the local oscillator in the pulse primary radar receiver is actually to produce what? Signal with the stable what? Frequency. That's the primary function of what? Of the local oscillator. So remember that we use also oscillators in transmitters to produce carrier signal in most cases. So you have to differentiate the oscillator we are using in transmitter unit and the oscillator that we are using in receiver unit. That's why we call them local oscillators. Say local oscillators. Let me just see, open your eyes. Tell your neighbor, get prepared for your eyes to be opened. Tell your neighbor, get prepared for your eyes to be opened. In telecommunication engineering system, we have transmitter, we have medium, we have receiver. Stop writing. Listen and watch. In any telecommunication system, whether it's internet, whether it is Wi-Fi, whether it is cellular, whether it is long distance communication, GSM, we have these three blocks or three parts. The first one, transmitter. The second one, medium. The third one is what? Receiver. In media, we have two types of media. Guided media and which we call wireless and the wired media. Right? So in transmitter, in most of the transmitters, we have something we used to call it oscillator. And especially for the wireless transmitters. Okay? We have what? Oscillators. And in most cases, it can be either RF oscillator or IF oscillator or microwave oscillator. The primary function is actually produce carrier signal. Right? 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 For the wireless for the wireless communication. Then remember that when this oscillator actual suppose that this is just the transmitter, it's a house or transmitter house, and this is the receiver. Listen. So this type of oscillator that you're using in transmitter, actually we don't call it a local oscillator. Why? Because once it's produced those oscillation, we expected the modulated signal to be propagated into the air, right? Or into the guided medium, whether into the air, but in most cases we say that let us discuss for the wireless. Then, either the case, or for the wireless, and even for what? Because in case of the optic fiber, it means we embed the information, we keep the information, the carrier signal there, it's a visible light. Okay? It's a visible light. So whether it's guided or unguided, in most cases for the long distance communication, carrier signal is important. So, this oscillator will produce the carrier signal. And then the carrier signal will be modulated with information signal. To mine is not in the class. Once we have a modulated signal, there's just a process of amplifying, reducing the noise, strengthens or increases the signal to noise ratio, etc., etc. Then this signal will be propagated to the medium by using what? An antenna, if it's wireless. And once it will be propagated into the medium, this is no longer, we call this the signal, the carrier signal produced by the oscillator and transmitter, it's no longer locally. Why? Because it's already, or it will be propagated outside of the transmitter unit. Okay? So this one will be actually propagated and be received by OT, by the receiver for the processing. Why do we call these oscillators we have receivers local? Say local oscillator. So the local oscillator that we find in most receivers, so in most telecommunication receiver, is actually producing a signal of the stable frequency, and that signal will be actually processed within the receiver unit. It will never get out. That's why we call it local. So the word local oscillator, it has a usual or just a common meaning, or a common and just the meaning of the word local. Say local. We used to have something called the local and the international, right? Yeah. For instance, myself, I thank God that I am a local teacher. How about you? Are you a local student? International students. Usually, you like to position yourself at the top. But it's better to position yourself at bottom. And then the nature will position you at the top. Well, so that's the means of local oscillator. So it means actually it produces the signal with a stable frequency. In most cases, it's used to be a radio frequency or just, yes, radio wave of a little bit different frequency from the one that will be received. And then the processing will be done within the receiver. That's why we call it a local oscillator. Right? Right? The oscillator that we have in transmitter, it's not a local oscillator. Why? Because what will be generated with this oscillator, it will be living outside of the transmitter and actually be propagated into the medium, and later will be received by the receiver. So that's why we don't call it a local oscillator. But this one we call it a local oscillator because actually it will produce the signal with a stable frequency, and then its output will be faded to the mixer, and then it will be mixed with the received with amplified RF, modulated RF echo signal to have IF, and then that IF signal or intermediate frequency signal will be, it's still intermediate frequency modulated or modulated intermediate frequency signal will be amplified by IF amplifier, and then still be actually demodulated by the demodulator or detector. And once the outputs of that demodulator will, or the demodulator itself will demodulate what has been produced by the local oscillator, and also to demodulate what has been produced by the oscillator in the transmitter to have the information signal. I know you say that, sir. Can you repeat again? Did you understand what I said? Yeah. Huh? Yes. What did I say to mine? Can you repeat for us? Yes. Summarize for us. Because Ashura did not understand the last point. Is this in the Ashura? Uh-huh. So present to us. What did you understand? Uh-huh. 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 We cook them. Oh. Okay, let me repeat what I have said. We still have some other blocks. How many blocks do we still have? 5. Right? The next block after local oscillator and the low noise RF amplifier, it's mixer. Right? The local oscillator will add something into the amplified, modulated RF signal. And then the output of the local oscillator will be fed into the mixer and combined with what? Amplified RF, what? Amplified modulated RF signal or echo. Right? Yeah. Then the outputs of the mixer will be fed into the IF amplifier unit. The intermediate frequency amplifiers will amplify what has been received from the mixer. Okay? Then the output signal with intermediate frequency from the IF amplifier unit will be fed into the detector or the modulator. Right? So the demodulator or the primary radar demodulator will actually suppress the signal from the local oscillator and the carrier signal from the oscillator, or just we call it, we used to call it RF oscillator of the transmitter, and give out only the pulse. So I know that you have understood, but just the challenge that you're experiencing when I have mentioned again the transmitter in receiver. So if you want to understand the mechanism, just stay connected. Okay? I've just give you a clue, introduction of where we're heading. So right now, remember that our echo signal now, or when we move to the when you move into the next part, which is actually the mixer. So we'll be having the echo signal, which is the pulse, which is what? Please make sure that you investigate the distance between the upper copy and lower copy of your neighbor. Because according to my research, the distance between the upper copy of your eyes, of your neighbor's eyes, and the lower copy is negligible. What does it indicate? Your neighbor is no longer in this class. When I'm trying my level best to explain about local oscillator and the RF oscillator, then your neighbor is actually very far and maintaining the distance between the upper copy and lower copy to be negligible. It's not measurable, it means. It's zero. And then again, we're executing simple harmonic. Okay, so stay tuned. I will explain it to you. So you say that the output signal of the local oscillator is fed into the mixer. Into what? Into what? The mixer. Now, waveform. Waveform of radio signal. Radio signal from oscillator, from local oscillator. This is voltage, this is time, this is zero. Telecommunication engineer is all about what? Graphs, eh? How about the graph between the lower copy and the upper copy of your eyes? Please draw the graph of your neighbors. So this is time, this is voltage. So this is figure what? Figure 3. Eh? You can notice the distance between the upper copy and lower copy of your neighbors. So that's what we can learn from there. Number 9, mixer. Say mixer.
Mixer.
according to the fundamental knowledge of analog electronics. The mixer. So in analog electronics, we told you that the mixer can produce signals Okay, so according to the fundamental knowledge of analog electronics, a mixer can produce signals can produce clean it, can produce both signals of sum or differences, sum or difference of their frequency. So the type of the mixer that we are discussing, it's a mixer that actually will be mixing the stable signal from the local oscillator and the amplified modulated RF echo. Okay? And then actually when it will be mixing, actually we say that what we want to say in this sentence, for instance, we say that the output frequency, double frequency from the mixer, might be the frequency of the signal from the local oscillator plus or minus the frequency of the amplified or echo. That's the meaning. So from this fundamental principle of working or knowledge of analog electronics, the mixer can produce both signals of the sum or difference of the frequencies. So that's why that we have wrote that if this is the output frequency or the output frequency from the mixer, then actually it will be either the summation of the frequency of the stable signal from the local oscillator and the frequency of the echo. Or it may be the difference between the frequency from the local oscillator and the frequency of the signal that has been received from the transmitter but has been reflected by the distant target. Are we together? So that's the meaning, that's the concept that we have to remember in case of the mixer. among the frequencies that has been produced by the mixer. Among the frequencies that has been produced by the mixer is intermediate frequency. Intermediate frequency, in short, you call TIF. So, Jafari is outside. So, a mixer has a feature or an ability to produce signals of the different frequencies, whether which is the result of the sum or the difference. So among those frequencies or those different frequencies that we can extract it from the mixer, it's intermediate frequency. Say intermediate frequency.
Intermediate frequency.
So simply the primary function of the mixer that of pass primary radar receiver is actual to convey the radio, or to mix the amplified modulated RF signal with the stable signal or the signal with the stable frequency from the local oscillator to give out a signal at the frequency, or to give out the echo signal at the frequency of what? Intermediate frequency, or at the intermediate frequency. So it means the mixer for this case is actually will be changing the frequencies. Remember that when we've been actually going through different videos of the different types of the radar, then you do remember that one of the radar was actually operating with the frequency of 2 gigahertz up to 8 gigahertz. Right? So gigahertz is actual, that's we call one of the spectrums or one of the frequency in radio frequency. So actually in the mixer, you find that they receive the echo possibly, it's in 2 gigahertz. So once it's been fed in the mixer, then that frequency will be lowered from the RF into the intermediate frequency. That's why we say that the pass primary radar receiver must be super hetero. Eh? So we expected it to have conversion of RF or original RF signal into the intermediate frequency signal. So what does it, which part is responsible for that? Local oscillator and mixer. Are we together? Are we together? Eh?
Yes.
So the mixer performs the addition or subtraction of frequencies of the signal from the local oscillator and the amplified modulated RF echo. So the output echo signal from the mixer is at a intermediate frequency, short call TIF. So now, from now onwards, or from this point, our echo signal is no longer in radio frequency. Our echo signal is in intermediate frequency. Are we together? Yes. To wind up this block, then let us discuss about waveform of echo signal from mixer. So the nature of the waveform will be a little bit changed, will be different only in terms of frequency, voltage, time. So the frequency of the carrier signal has been changed. Can you examine the graphs of your neighbors now? The graphs that to check if your neighbor is drawing what I have been drawing or drawing something else. Please, on my behalf, examine the graphs of your neighbor on your left-hand side and right-hand side. I believe that some of them will make you to laugh, because you'll see something different from the one that I drew. I say, please check the graphs of your neighbors on your left-hand side and right-hand side. If they look the same, what you've been drawing, or something different? Something different, yeah? Yeah. Why? Because your neighbors don't care. Yes, it's just a graph. This is figure what? So remember that for this one, or for the previous graph, figure 7, the waveform or the amplified modulated radio frequency echo, it's in RF frequency. This one, it is in IF, IF 40 frequency. So if I could be you today, I could have not taken a sleep and know about the bandwidth. RF frequency, where does it start? What the minimum value of RF frequency and maximum? Then I will make sure that I won't sleep until I know the bandwidth of IF. What the frequency of intermediate frequency? What the minimum frequency? What the maximum frequency? If I could be you. But because I'm not you, whenever that I will end, even yourself will end there. But just keep on ending where we end. Then we'll enjoy one day. Figure 9. So figure 9 is what? Wave form of what? Of echo. Echo intermediate frequency signal from mixer. Class, is it clear? Yes. I said if, subwriting. If I could be you, say, if my teacher could be me. Just to say that, if I could be like my teacher. Tonight, I won't take a sleep until I remind myself the boundaries of RF signal and the boundaries of intermediate frequency. Because if you don't know the bandwidth, you just mention RF signal, then you don't know what the frequency of that RF signal, what the frequency of electromagnetic waves should have until it's called RF signal. And what the frequency of the signal until it is called the intermediate frequency signal. Right? You're a telecommunication engineering student. Those are the stories, those are the numbers should be in your mind. That you know, what do you have in your mind? It's actually the score between Yanga and Azam. So you remember the goals. You remember that how many games Yanga has won, but you don't remember about the boundaries. Okay, then we go, we are moving to the block number what? Number 10. What its name? What?
Intermediate frequency amplifier.
Again?
Intermediate frequency amplifier.
Again?
Intermediate frequency amplifier.
Because I know you like abbreviation. IF. IF amplifier. Intermediate frequency. It's just like EF. Intermediate frequency or IF amplifier. Intermediate frequency or IF amplifier. Say intermediate frequency.
Intermediate frequency
Amplifier. So what is going here? Something wrong. Okay. So, if you've been understanding about what I'm teaching you, who can tell me that? What do you have here? How many signals do you have there which have been combined together? Two. So to mine said 2. How many signals do we have there? How many signals have been combined until we have this nature of the waveform? Sophia? 2 signals. Geoffrey? 2 signals. Lillian? 2 signals. Hamza? 2 signals. Why 2 signals? Only 2 signals. Only 2 signals. Wonderful. Jafari? 2 signals. Daudi? 2 signals. Binuru? Binuru? Binuru is not there, She has escaped. Are you sure? Isaac! Isaac was not in the class. Why? Because he said that he did not hear the question. Why 2 signals? My friend? Answer the question. 2 signals. Mention them. Local signal and echo signal. John Dean, tell us. 2 signals. Mention them. Jafari way. So 2 signals, Jafari and Tumaini. So once Tumaini has established 2 signals, and then everybody say 2 signal, 2 signal, 2 signal. Are you really using your common sense? Or you just want to hear something and then you don't care. You just mention 2 signal, 2 signal. No, just gratitude, 2 signals. So that seemed like you didn't understand what you've been learning. So you have to make sure that you go through this video several times. Because there we don't have 2 signals. You say yes, but the issue is now how many signals do we have and why are those numbers of the signals. So you have to review lecture 6 and lecture 7. Then you'll understand how many signals do you have there. Intermediate frequency amplifier. Say intermediate frequency amplifier.
Intermediate frequency amplifier.
So, maybe, have you ever heard about this amplifier? It's first time to hear it, yeah? Is it your first time or you have heard it? So what is it? You heard it and then you left it. So what is IF amplifier? So the intermediate frequency amplifier, the IF amplifier, is the type of telecommunication amplifier that amplifies information signal at the intermediate frequency. So in electronics, we have electronics amplifiers, stop writing. And also we have electronics telecommunication amplifiers. Those are the 2 different categories. Can I repeat? Huh? Yes. Listen. Stop writing and listen. In electronics engineering, we have 2 categories. So do you see your neighbor? Do you see backbencher there? He's busy chatting. That's my students. What did I say? In electronics engineering, we have 2 categories of amplifiers. First of all, the topic of amplifier, it's a huge and very interesting in electronics engineering, more than you think. So we have 2 categories of amplifiers. The first one, we call them electronics amplifiers, which amplifies electric signal into another shape or another strength or intensity, where that information, so electric signal, is not information signal. And also the second category, we call them electronics communication amplifiers. So electronics communication amplifiers, these are the amplifiers which are used in communication or telecommunication system. Right? Right? Yes. So one of that type of communication or telecommunication amplifier is intermediate frequency amplifier. Say again, intermediate frequency amplifier.
Intermediate frequency amplifier.
So the main function or the primary function of this amplifier is to be used in communication system. It's just like RF amplifier. RF amplifier, as the name itself, it's usually used in communication. Are we together? But remember that we need amplifier. For instance, myself right now here, I'm using a microphone. I can have just a local amplifier, which is not actually the RF amplifier. If there is no any wireless communication, I can have a wired. If I have a wired microphone, gratitude is busy. If you have a wired microphone, for that case, there is no need for the RF amplifier. I'll use another communication amplifier, but it's not the RF. So simply remember that we have two categories: communication amplifiers or telecommunication amplifiers, or we call electronics telecommunication amplifiers and electronics amplifiers. My sister there is busy. Busy taking a note about two categories of amplifiers. So, with regard of the pass primary radar receiver, we say that the IF amplifier, the intermediate frequency amplifier, used in pass primary radar receiver. Primary radar receiver allows only the intermediate frequency. Which is I'm about to end this lecture, which is obtained from the mixer. From the mixer. And once it receives it, and it amplifies it. And amplify it. So the IF amplifier used in pass primary radar receiver allows only intermediate frequency signals. Intermediate frequency what? A signal. From what? From the mixer. And once it receives this signal, it amplifies. So if the signal from the mixer is not at the intermediate frequency, then the IF amplifier will not receive that signal. Those are the techniques that we have to remember whenever you want to do maintenance of the radar system. So the waveform, so I think that you know that what will be the waveform? The nature of the waveform? High amplitude than what? Than which one? Which one? That one. Waveform of amplified IF signal, IF echo signal. So remember that the frequency of this signal now has changed from RF. So for the RF, the frequency is high. Intermediate frequency is always less than RF frequency. Be careful. Okay. So the waveform of amplified intermediate frequency echo signal. Ask your neighbor, how many waveforms did you learn up to this time? In primary radar, how many? Only one? Ah, very good. This is figure what? Figure 10. It's what? Waveform of what? Amplified what? Echo. Echo intermediate frequency. Thank you. Echo intermediate frequency signal. So this is the waveform. And that's all about block number 10. Block number 11. Pardon? Who told you? You can go. Block number 11. It's called what? Detector. Detector, or we call it demodulator. Demodulator. So say detector or demodulator. Now a few students who are saying, fine. Say detector or demodulator. So you are familiar with different types of demodulator, but simply this one we say that the detector used in pass primary radar's receivers is used to demodulate the received intermediate or echo intermediate frequency from the IF amplifier. So we say that the main function of detector is actual to demodulate. Say demodulate. Say demodulate. So demodulate what they receive the echo intermediate frequency signal from the IF amplifier unit. So what is demodulation? So demodulation simply, it's just a isolation of the information signal from the modulated signal. Or in other ways, you say that demodulation simply, it's a process of suppressing the carrier and the stable signal from the local oscillator and give out only the information signal, which is a short burst of pulses. Okay? Yes, let me write. So you say that the demodulator suppresses what? Suppresses the carrier and the carrier signal, so the RF carrier, and the stable signal from the local oscillator. So the demodulator or the detector suppresses, say suppress. Say suppress. So suppress the RF carrier and the stable signal from the what? From the local oscillator and give out gives out the short pulses or the short burst of pulses. But the function of the demodulator. So remember, the pulse generator, it actually generated only the pulse. So the output of the demodulator, it's what actually has been generated by the pulse modulator. So this one will suppress the signal from the local oscillator and also the RF carrier signal from the RF oscillator. Right?
Yeah.
Right?
Yes.
So the waveform that will be sent to the display, which is the last part, the waveform of received or demodulated signal, waveform of demodulated, the waveform of demodulated signal. This is the waveform of demodulated signal. This is time, this is voltage. So remember that even the amplitude is still the same with the one that we drew in the pulse generator. So you have to make sure that the amplitude should be the same, right? Yes, because what the transmitter is transmitted is actually what you expected to extract it from the receiver. So the waveform, I'm not sure about the amplitude, the size of the amplitude. This is just a sketch. But for you, you can check the size of the amplitude and measure it and then draw. This is what will be the output or the modulated pulse signal. The modulated pulse signal. And this is what the transmitter or the radar transmitter has transmitted. Are we together?
Yeah.
Are we together?
Yes.
To mine. Okay, so this is figure 11. They received the pass signal. Received the pass signal. So this is the one. Hey! This is the one carrying what? All the radar parameter. Which radar parameter? It's the one that can give us range. It's the one that can give us what? Range of the target. It can give us what? Elevation angle, azimuth angle, radical velocity of the moving target. Right? This is what we have been discussing in introduction. But remember that this is the puzzle. You cannot understand the range and the whatever and those parameters. So you need again, or this will be just the weak OT, will be the weak signal. So if the weak signal, then we need to amplify them. That's why we have an XC block, which is called OT, video amplifier. Video what? Say video amplifier. Class, say video amplifier. Video amplifier. Yeah, thank you. So this is the 12th block. So remember that a video amplifier, somebody asked you what the means of a video amplifier. A video amplifier, this is another type. It's a type of telecommunication. It's a type of telecommunication. Telecommunication. This is the type of telecommunication amplifier. Amplifier, telecommunication amplifier that amplifies what? The video signal. So this is the type of the telecommunication amplifier that amplifies what? Video signal. Say video signal. Video signal. Say video signal. Video signal. So it means that these passes now carry video information. So you say video is a combination of what? Picture and the sound. But for this case, it's just only the picture. But it's dynamic picture. Because you have still pictures and dynamic picture. So we call it a picture if it is still. Right? But in case you have moving pictures, we call them video. Even if we don't have an audio. Are we together? Is it clear? Yes. So where does it get the video signal? So the video amplifier the video amplifier of the pass primary radar amplifies the pass video signal from the demodulator. So its primary function is actually to amplify what? Pass video signal. From what? From what? From what? From the modulator. That's the primary function of the video what? Amplifier. So what will be the waveform? Ask your neighbor. In this tonight, you'll dream about waveform, eh? Eh? So waveform of amplified pass, amplified pass video signal. So remember that the nature of the waveform still pass, right? But you'll have what? High amplitude. So this is figure what? A. Figure what? 12. In some past, so stop writing, listen. In some past primary radar system, after having the block of video amplifier, there is another block which is called threshold detection. Say threshold detection. The primary function, in case of our general block diagrams, we don't have it, but let's just explain to give you an idea. The primary function of the threshold detection in past primary radar receiver is actual to make decision, to compare the received signal with the transmitted signal. In case that the received signal has the characteristics, the same characteristics with the transmitted signal, then the detection, the threshold detection will allow the received signal to be transmitted towards the display. In case the received signal is completely different from the one which has been transmitted, then the threshold detection will suppress. It will suppress what? The pass video amplified signal. Madam, can you repeat behind Daud? What's your name? What's your name? Huh? Jamila. Huh? Amy? Neema. So the sound of my sister there is wonderful. Okay. So the threshold detection is actual to make the comparison. What has been transmitted, what has been received. If the received signal is the same with the transmitted, then the signal will be passed to the next block. That is what? Radar display or radar CRT display. Anna is chatting. Anna is? So when I'm explaining about radar threshold detection, Anna is chatting. So because Anna is chatting, let us continue. Then Anna will tell you about what I wanted to explain. The last block is display. Right? We call it CRT. CRT. Cathode, ray, tube what? Radar what? Display. So first of all, we say that most radar system uses the cathode ray tube displays. To display the video, to display the amplified video, display the amplified video of the target. So I think we have been going through different videos that actually trains us or just demonstrating about radars, and then you notice that radar systems uses what? CRT screen. CRT what? Yeah? It's just like the oldest screen, the oldest television receiver screens. You'll draw them later, eh? So, the pass CRT display the CRT the pass CRT display displays the pass, the amplified pass video signal. So the pass CRT display displays the amplified pass video signal received from the video amplifier. Then that's all about principle of operations of pass primary radar. Class, is it clear? Yes. Eh? Yes. So how many types of electronics communication amplifiers did we learn in pass primary radar? How many types? Eh? The question is too much simple, very simple. How many types electronics communication amplifier did we learn in this part? Eh? Pardon? Eh? 3. The first one? Eh? So you are reviewing the previous notes. You have already forgotten. Eh? Pardon? Low noise? Low noise amplifier? Intermediate frequency amplifier? Video amplifier. Then you didn't understand the other type, the first type of amplifier, which we covered in transmitter. It's called the RF high power amplifier. Okay, keep enjoying. Okay, so this is the end of principles of radar system, but it's the time for me to give you an assignment. This is assignment 1. And it's very simple. The first question. Draw the clear general block diagram of continuous wave primary radar system. This is the first question in this assignment. The second question, explain briefly the principle of operation of CW, continuous wave primary radar. Hint. Describe each block. So in lecture, so that's the assignment. Before I explain, just give you a short description about the assignment. Let me just tell you what we have done in lecture 5, lecture 6, and lecture 7. Stop writing. In lecture 5, lecture 6, and lecture 7, I've been teaching you 2 main concepts about radar system. I've been teaching about the general block diagrams of the pass primary radar, and I've been teaching you the principal operations of the pass primary radar. So I have given you the guidance. How should you draw? And actually I expect you to have a very clear, and don't write this assignment because you are writing towards me. You have to make sure that you study, you read different sources. I know there are different block diagrams of the continuous wave primary radar system from different sources. Some of them are correct, some of them are not correct. So I want to give you a warning. Make sure that you read different sources and you understand. Then you just draw the one which is actually presenting the whole picture of continuous wave primary radar. Even myself, when I've been preparing the notes for the past primary radar, I found different general block diagrams about past primary radar, but I chose the one which is actual, has a link. Some of them are not correct, some of them are correct. So as how I have taught you in lecture 5, lecture 6, and lecture 7, it's your responsibility now to go and work for the continuous wave primary radar. That will be a very interesting assignment for you in the next weekend. Are we together? Remember that it carries a number of the marks. It's individual assignment. It's individual assignment. It's individual assignment. And carries 10 marks. Make sure that you may discuss with your colleagues, but make sure you write your own work. Student, listen. You are allowed to discuss with your colleagues. You are allowed to go through different sources with your colleagues, but make sure that you write your own work. In case I find similar assignment or similar, just the same parts, then I will take measures to you. Are we together? Class, are we together? Yes. Yeah, so we discussed what the means of continuous wave radar, whatever. I've given you the introduction. So nothing is difficult there. You can go through about them. And make sure that in your description, you include the block diagram. And in your descriptions, question number 2, you just provide the short description and the waveform. As how I've taught you. And what? And what? Okay. So if that's the case, this is the end of lecture 7. I would like to take this opportunity to ask you, did you understand what we have covered or you haven't understood? So let us appreciate you for understanding by congratulating you. 1, 2, 3. Hongera. Imara. So thank you very much for the online community. This is the end of lecture 7. I would like to invite you in lecture 8 when that we are going to discuss about different other concepts concerning about radar and navigation aids. If you found that these contents are helpful and actually they are opening your mind about telecommunication engineering, then I would like to ask you to register yourself and becoming a serious and not a temporary students in our official online channel where that actually we used to contribute and actually publish different videos about telecommunication engineering, about electronics engineering, about computer engineering, about biomedical engineering, about mechatronics engineering, about electronics engineering, and also about electrical engineering. So make sure that you just click the buttons of subscribe for you to receive notification whenever we publish a video. We are trying our level best to be serious and very committed in that official YouTube channel so that to make sure that we upload at least or we publish at least 1 video in a week. So if that's the case, thank you very much. May God bless you. I expect to meet you in lecture 8. Bye-bye. Be blessed.
Hekima, umoja na amani. be